Okay, I'm going to make a very quick video about balancing equations because some people are struggling and not everyone could be in class yesterday because I went through in class how to balance one of the two decomposition reactions which we had in the lab on Tuesday. So what I did in class yesterday was I balanced the reaction between copper 2 sulfate and potassium iodide, aqueous solutions. I don't know if this is going to work. I'm really pushed for time, so I'm just going to try and hold this camera above this bit of paper and hope that you can see what I'm doing. This is what I'm hoping. Okay, so let's see if this will work. Hang on, it's not going to work for a second because I've just put it down. Hopefully you can hear me, and I'll just get the formula to make it faster. Okay, so can you read that? It's copper 2 sulfate, so I could have put the 2 in there. Aqueous reacting with potassium iodide. Okay, now it's going to go in and out. Now the first thing you do is you check. Now that is the correct formula for copper 2 sulfate. The charge on the copper is 2 plus. Charge on the sulfate is 2 minus. Charge on the potassium is 1 plus. Iodide is 1 minus. Okay. Now we think we're going to produce, and it would be reasonable to think that we were going to produce, if there was a displacement reaction, the copper reacting with the iodine, so copper and iodine. Now in this case, if the copper retained its 2 plus charge, which is reasonable to expect, the formula for the copper iodide would be CuI2, so 2 plus, and the iodine is 2 times 1 minus. Yeah. Then the other possible product is that we would have potassium sulfate. So for the potassium, it's potassium and then the sulfate. But what we happen to know is that sulfate has got a charge of 2 minus, so we would need 2 of the potassiums to balance the charge against the sulfate group. Are you clear? Hopefully you are. Then what happens is you say, well, if I've got 2 potassiums here, I've got to balance it across to the reagent side of the reaction, so I would actually start the experiment with 2 molecules of potassium iodide. Okay. Now if that is the case, then we've now got a balanced reaction. One atom of copper on both sides, 1 molecule functional group sulfate on both sides, 2 potassiums on both sides, and 2 iodines on both sides. But this is more complex because we've got decomposition. So decomposition is occurring because copper 2 iodide is not stable. So what happens with copper 2 iodide is that actually it breaks down, and it breaks down in the following way. Copper 2 iodide, okay, in that form, it actually breaks down according to the following formula. It decomposes into copper iodide. Now that's copper 1 plus iodide. We don't normally put those in, okay. Copper 1 iodide and iodine, okay. Now this is not balanced, okay. This is not balanced. So what we have to do is we say, well, actually we've got 3 iodines on both sides, yeah. So what we'll have to do there is say, well, let's see if we can multiply this by 2. Let's see if we can get this to balance. 2 iodines, so there are 4 iodines. Well, there's 2 there. Oh, we've got a problem. It's still not balanced. Hang on, if I've got 2 coppers, I'll need 2 coppers there. And that actually now balances the decomposition reaction. 2 coppers, 2 coppers. 4 iodines. There's 2 and there's 2. Okay. So what we've got then is a 2-stage reaction where we're actually going from this side of the first equation to this sort of intermediary phase, which actually then breaks down into these products. Okay. Now what we've got to do now is get this side, this, to balance completely over the whole equation. So what I've done here is I'm going to go through a couple of steps and see if I can get this to work. What it means is, let's start writing it out again, okay? Copper sulfate, copper 2 sulfate, aqueous, plus 2 potassium iodide, aqueous, is going to yield 2 copper 1 iodide plus iodine plus the potassium sulfate. So I'll take the potassium sulfate as we've written initially, okay? But what we have now is we've got an unbalanced formula because we've got 2 coppers here and we've only got 1 on this side, okay? So what I'm going to do is I'm going to say, right, I'm going to multiply that by 2. So now I've got 2 coppers on both sides of the equation. Yep. Because I've multiplied that by 2, I've also multiplied the sulfate group by 2. So that means that I would have 2 in front of the potassium sulfate. You see that? Having done that, I've now produced a situation where I've got 2 and 2, I've got 4 potassiums. So that has a knock-on effect. So I come back to here and I have to multiply that by 2. So I've actually now going to change that into a 4. Okay? So now I've got my 1, 2, 3, 4 potassiums on this side and my 4 potassiums on that side. That means I've changed the number of iodines on this side. I've got 4 iodines on this side of the equation. How many have I got on that side? Well, I've now got 2 iodines here, and I've got 2 iodines here. So actually, I've now got a balanced equation for the whole reaction. So if we write it out neatly, I'll stop blurring. This is hard to film and write at the same time, but I hope you can see it. So now the equation for the whole reaction will be as I'm writing, okay, will give us 2Cu I plus I2 plus 2K2SO4. Now in terms of the states, aqueous, if one looks up in the tables, copper 1 iodide is actually insoluble, so it's solid, it's precipitate. Yeah. Iodine rather, is insoluble in water, so that forms a solid. And potassium sulfate, which hopefully you can read, is aqueous. That is the first of the decomposition reactions balanced. Hopefully that works for you guys. It's the best I can do. I've got someone coming for a meeting now, and meetings for the rest of the afternoon. I'm going to try and publish this to YouTube. I haven't done it before. Give it a go. That should form the basis of then how you work out the other decomposition reaction, which involves the copper chloride, copper 2 chloride, and the potassium iodide. It's very similar. Okay? You should be able to work it out. All right. Good luck. This is way longer than I meant it to be.